Parallel lines cut by a transversal. Lines L1 and L2 are parallel lines. Parallel lines are lines that are always exactly the same distance apart. Parallel lines will never touch, no matter how far the lines are extended. Line L3 is a transversal. A transversal is just a line that cuts across two or more, usually parallel lines. When two parallel lines are cut by a transversal, 8 angles are formed. So we have angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. We want to talk about the relationships between these angles. So the first relationship we want to talk about is vertical angles. Vertical angles are angles that are opposite to each other. They share only a common vertex, but no common sides. So angle 1 and angle 4, you see that they're opposite to each other. They share only the common vertex. Their sides don't touch. Angles 2 and angle 3, they're opposite to each other. They share only a common vertex, but no common sides. On the bottom portion of our diagram, angle 6 and angle 7 are opposite to each other, sharing only a common vertex. And angle 5 and angle 8 are opposite to each other, sharing only that common vertex and no common sides. Angles that are vertical to each other are going to have the same degree measure. So angle 1 is equal to angle 4. Angle 2 is equal to angle 3. Angle 6 is equal to angle 7. And angle 5 is equal to angle 8. So I can sum it up by saying vertical angles are equal. Another relationship formed when the parallel lines are cut by a transversal would be corresponding angles. Corresponding angles are on the same side of the transversal, and they open in the same direction. So if I look at the left side of the transversal, I have angles 1, 3, 5, and 7. So on the left side, with angles 1 and angle 5 open towards the top of the page. So angle 1 and angle 5 are considered to be corresponding angles. Still on that left side of that transversal, angles 3 and angle 7, they open towards the bottom of the page. So they're considered to be corresponding angles. Let's look at the right side of the transversal. On the right side, only angles 2 and angle 6 open towards the top of the page. And angle 4 and angle 8, well, they open towards the bottom of the page. Angles that are corresponding to each other are going to have the same degree measure. So angle 1 equals angle 5. Angle 3 equals angle 7. Angle 2 equals angle 6. And angle 4 is equal to angle 8. So I can sum that up by saying that corresponding angles are equal. Alternate interior angles are angles that are inside the parallel lines, like angles 3, 4, 5, and 6, but opposite sides of the transversal and not next to each other. So inside the parallel lines, angles 3 and angle 6 are on opposite sides of the transversal, but not next to each other. Still inside the parallel lines, angles 4 and angle 5 are on opposite sides of the transversal, but not next to each other. Another way to identify alternate interior angles are angles that are inside the parallel lines and on the diagonal. Or you could say that alternate interior angles form an X inside the parallel lines. Any angles that are alternate interior to each other are going to have the same degree measure. So angle 3 equals angle 6. Angle 4 equals angle 5. So I could say that alternate interior angles are equal. Now, alternate exterior angles. These are angles that are outside the parallel lines. So angles 1, 2, 7, and 8, they're outside the parallel lines. They're on opposite sides of the transversal, but not next to each other. So angle 1 and angle 8, they're outside the parallel lines, opposite sides of the transversal, but not next to each other. So angles 1 and angle 8 are alternate exterior to each other. Angle 2 and angle 7, they're outside the parallel lines, opposite sides of the transversal, but not next to each other. Any angles that are alternate exterior to each other are going to have the same degree measure. I could sum it up by saying alternate exterior angles are equal. So in this diagram, let's let angle 7 be equal to 53 degrees. We want to find the measure of the other angles. Well, I know that angle 7 and angle 6 are vertical to each other. You're opposite to each other, sharing only the common vertex. So vertical angles are equal. Angle 6 has to be 53 degrees as well. Right now, inside the parallel lines, opposite sides of the transversal, but not next to each other, kind of on the diagonal, inside the parallel lines, would be angle 3. So angle 6 and angle 3 are alternate interior to each other, and alternate interior angles are equal. So if angle 6 is 53 degrees, so is angle 3. Okay. Angle 3 and angle 2, they're opposite to each other, sharing only a common vertex. So angle 3 and angle 2 are considered to be vertical angles. Vertical angles are equal. So if angle 3 is 53 degrees, angle 2 will be 53 degrees. Now let's go back to angle 7. It's angle 7 and angle 8 form a straight angle or straight line. So we'd say that angle 7 and angle 8 are supplementary. Supplementary angles have to add up to 180. So to find angle 8, the measure of angle 8, all they have to do is subtract 180 minus angle 7 minus 53 degrees. So I see that the measure of angle 8 is 127 degrees. Now, directly opposite angle 8, sharing only a common vertex, would be angle 5. So angle 8 and angle 5, they're vertical to each other. So vertical angles are equal. If angle 8 is 127 degrees, so is angle 5. Inside the parallel lines, kind of on the diagonal from angle 5, is angle 4. That's alternate interior. Angle 5 and angle 4 are alternate interior angles. So if angle 5 is 127, so is angle 4. You know, kind of on the diagonal inside the parallel lines. And directly opposite that, sharing only a common vertex, would be angle 1. Angle 4 and angle 1 are vertical angles, and vertical angles are equal. So we want to determine if the angles in the figures below are vertical, corresponding, alternate interior, alternate exterior, complementary, or supplementary. So in diagram A, angles 1 and angle 2, they're outside the parallel lines, kind of on the diagonal. You know. They're opposite sides of the transversal, but not next to each other. These are alternate exterior angles. For B, angles 1 and angles 2 are opposite to each other. They share only a common vertex. So we'd say that angles 1 and angle 2 are vertical to each other. In C, angles 1 and angle 2 together form that straight angle. So we could say that angles 1 and angles 2 are supplementary. For D, angles 1 and angles 2 are both on the left side of the transversal, so they're on the same side of the transversal, and they're both opening to the top of the page. So angles 1 and angles 2 in diagram D would be corresponding. For E, here, angles 1 and angles 2 are inside the parallel lines, opposite sides of the transversal, but not next to each other, or inside the parallel lines, but on the diagonal. These are alternate interior angles. In F, angles 1 and 2 together form that right angle. So angles 1 and angles 2 are complementary.